welcome dear students. We are on the CEC Gurukul lecture and we are in the series of the electronic circuit. And up to now we discussed the many electronic gadgets which are used in the development of the electronic gadgets. Nowadays we are discussing about the display devices, which is one of the most important just to get the output in the form of the text, pictorial or in the form of the video. So what are the display devices? We have discussed one of the important device which is the CRT, cathode ray tube or cathode ray oscilloscope, that is generally used in the laboratories for getting the output of any electronic circuit. Moreover, there are other devices also. So we will discuss one by one. Next device we will discuss today is the raster scan display. What are the raster scan display, which is the most common type of the graphic monitor, which employs CRT, and it is based on the television technology, and in the raster scan electron beam sweeps across the screen and the top to down, covering one row at a time. It means in the raster the electron beam sweeps across the screen in the top down manner, which covers the one row at a time. So a pattern of the illuminated pattern of the spots is created by turning beam intensity on and off as it moves across the each row. The pattern which is illuminated through the spot, which create by turning beam intensity on and off as it moves towards the row backward or the forward. So when this spot move in the row, and it generate the output. A memory area which we use is the refresh buffer or the frame buffer that stored the picture definition. So in the raster scan, the picture we will get in the form of the output, and this memory area which contain the buffer of the picture that holds intensity values for all the screen points. As the point is moving on the screen in the form of the row that stored in the memory, and that holds the intensity value of each screen point on the screen. So stored intensity value are stored from frame, buffer and painted on the screen, taking one row at a time. It means when we get the output, it comes from the row by row. First row will give the value, intensity value, then another row, and in this manner we get the different values. So each screen point is referred to as the pixel. The point on the screen is referred to as a pixels. So in raster scan system, refreshing is done at a rate of 60 to 80 frames per second. Refreshing means where we are just taking the screen points on the output screen, so which is stored in the form of the memory. So in the raster system, refreshing is done at a rate of 60 to 80 frames per second. And refresh rates are also sometimes described in units of the cycle per second per hertz, that defined in the form of the intensity, and the unit of it is second per hertz. At the end of each scan line, electron beam begins to display text scan line after returning to the left side of the screen. Means it will scan the first line, first row, then the electron beam begins to display next scan line after returning to the left side of the screen. Again it comes on the first point of the next row. So the return of the left of the screen after refresh of the each scan line, that is known as the horizontal retrace of the electron beam. Means here what we are doing, we are taking the row by row scanning and then row by row, but it is in the form of the horizontal retrace. So at the end of each frame, electron beam returns to the top left corner and begins the next frame. at the end of the each frame, electron beam returns to the top left corner and begins the next frame. You see on the screen that here we are having the different scanning value. You see, this is a horizontal retrace. Right hand side, you see on the first figure that there is a horizontal retrace, and at the bottom we are having the vertical retrace. So the in between that we are having a pixels, and you see on the lower picture, you see that here on the one right hand side we have the vertical traces, horizontal traces, retraces also, and there is a scan line where the electron beam are when the points of the pixel we are scanning. So this is the raster scan display. So in the raster scan display, the electron beam is swept across the screen one row at a time from top to bottom. As the electron beam move across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. These illuminated spots make the pattern on the screen through the scanning of the electron beam across the each row. And moreover, the picture definition is stored in the memory area that called the refresh buffer or the frame buffer used for the read drawn. And after getting the output through the illuminated spots, we can store in the form of the picture in the memory area. Each screen point is referred to as a pixel, and that is also called a PEL, and the picture elements. So each screen point is referred to as a pixel or PEL, that is the picture element. Refreshing on raster scan display is carried out the rate of 60 to 80 frames per second, and the unit of the refreshing rate is in the hertz. You see on the screen, you see here that screen is representing that how the raster scan is moving from in the horizontal manner from row by row. You see there is a scanning point. Picture 1, the scanning of the first row. After that, row by row scanning is going on, and you see on the C that pattern we are getting, and on the D we see that the last point again the pixel will go to the first point on the left hand side of the starting row. Now, raster scan display processor. What is this? It is an important function of the display processor is to digitize a picture definition given in the application program into a set of the pixel intensity value for storage in the refresh buffer. So for that we have to use the processor. So the process is referred to as a scan conversion. The purpose of the display processor is to relieve the CPU from the graphic jobs. So display processors can perform various other tasks like creating different lines, style, displaying color areas, etc. Typically, display processors are utilized to interface into the devices such as mouse and joysticks. So you see on the screen, this is the one type of the display processor of the raster scan device. So you see on left hand side we are having the CPU, memory devices, and there is a system bus and input output devices, and the monitor that can give the output. So in this manner we can get how many type of scanning or the traveling of the beam in the raster scan. In the raster scan we have the two type of beam. First is the interlaced scanning, second is the non-interlaced scanning. So in the interlaced scanning, what we have, each horizontal line of the screen is traced from top to bottom. Each horizontal line of the screen is traced from top to bottom, due to which fading of display of the object may occur. This problem can be solved by the non-interlaced scanning. In this, first of all, the odd number lines are traced or visited by an electron beam, then in the next circle even number of lines are located. That's the difference between the interlaced and the non-interlaced. In the interlace, the tracing from top to bottom of the horizontal lines, but in the interlace there is a there is a different type of mechanism where first the odd number lines are traced, then the in the next step the even number of lines are traced. So, these are the difference between the rasters, types of the raster scanning display devices. Moreover, the non-interlaced display refresh rates of 30 frames per second we will use, but it gives the flickers. For interlaced display refresh rate of the 60 frame per second is used, means the interlaced working more faster as compared to the non-interlaced. Next, what are the advantages of this type of display devices? Real time images with different shades can be displayed, colored range available is bigger than the random scan displays in the raster scan. Moreover, there are disadvantages. Resolution is lower than the random scan display devices. Moreover, the more memory is required. Data about the intensity of all the pixel has to store. So it is a different type of the disadvantages, but more advantages are that real time images we can get with the different shades to display. Colored range available in this type of the raster scan. Next type of the display device is the random scan display, that is different from the raster scan display. This in the random scan display, electron beam is directed only to the area of the screen where a picture has to be drawn. It means it does not scan all the area, but only the area of the screen where a picture has to be drawn, and it is also called the vector display, as it draws a picture one line at a time, and it can draw and refresh component lines of the picture in any specific sequence. So, in the random scan display, the electron beam is directed only in the area of the screen where a picture has to be drawn. So, a pen plotter has a pen plotter is an example of the random scan device. The number of lines regulated refresh rate on the random screen display. So, as the name suggests, randomly we are distributing the points of the pixel we are taking and to present the picture. So, a pen plotter is an example of the random scan device. The number of lines regulate refresh rate of the random scan display. So, an area of the memory called refresh display lines stores the picture definition as a set of the line drawn commands. So, you see on the screen that here we are having the high quality vector system can handle around 10,000 short lines at this refresh rate. Faster refreshing can burn phosphorus. So, the system returns back to the first line command in the list after all the commands have been processed. So, it will take only the particular area where we are drawing. So, to avoid every refresh cycle is delayed to prevent refresh rate greater than the 60 frames per second. Suppose we want to display a square of A, B, C, D on the screen, the command will be like that: draw a line from A to B, then draw a line from B to C, then draw a line from C to D, and draw a line from D to A. It is randomly distributed as it works, not scan all the screen, but it take only that area where we are drawing the line. So, you see random scan display devices, you see directly it is not scanning, it is directly just giving the best picture presentation. Like random scan display system draws a set of lines in any order. It may be the triangle, you see on the screen that the triangle is going to be drawn through this random scan device. So first we take the right hand side you see, and in the last picture we are seeing that there is a full triangle display through the random scan display. Random scale display processor used, it is a form of the application program is stored in the system memory along with the graphics packages. So, graphic packages translate the graphic command in the application program into the display file storing a system memory. This display file is then accessed by the display processor to refresh the screen. Moreover, the display processor cycle through each command in a display file program. Here just we see that all the command given, the what type of picture we are drawing, only the commands will be given to the display processor and it will draw accordingly. So sometimes the display processor is random scan is referred as a display processor unit graphics controller, or it is also a graphic controller. You also listen that there is a graphic controller card in the memory devices. So that will store the points, then it will that will store the points and then it will convert into the graphics. So the structure of a simple random scan, here we are again same, the CPU, system memory, display processor we are using, and then the monitor we can get the output, and here input devices are connected with the system bus and system bus connected with these CPU and system memory and display processor. So what are the advantages? Higher resolution as compared to the raster scan, produces a smooth line drawing. Moreover, we have the less memory required in it. And what are the disadvantages? It is realistic image with the different shades we cannot be drawn. Moreover, color limitations in this random display devices. So there are some advantages and some. What are the difference between the raster and random scan devices? We will discuss one by one. First, we discuss on the basis of the resolution. Raster scan resolution is very low, and because of the picture definition is stored as a intensity value. But in the random scan, its resolution is high because it is stored as a group of line commands. In the raster, we are having the intensity value, but in the random, we are having a group of line commands. Next comparison is the cost. Raster is less expensive as compared to the random scan devices. Refresh rate is 60 to 80 frames per second in the raster, but in the random scan refresh rate is 30 to 60 times per second. Another is the picture definition. It stored the picture definition in the refresh buffer. Moreover, it stored the picture definition in the refresh display file. Raster store in the refresh buffer, but random store in the refresher display file, which is in the display processor. Apart from that, here we are having a line drawing. Line drawing in the raster scan, this provides a zigzag line as a plotter value is different, but it provides a smooth line as the line path is followed by the electron beam. So image drawing, another comparison is the image drawing. Pixels are used to draw images in it. Means raster use the pixel to draw the images, but in the random it use the applications and the mathematical functions to draw the picture. So we require the programming in the random as compared to the raster scan, because here we the display processor. So these are the basic difference between the raster and the random scan. Next point is the colored CRT monitor. That is also one of the display device that is used to display the output of the electronic circuit. So what is this colored CRT? This colored CRT means colored cathode ray tube. Generally in the laboratory we are having the black and white, and we are having the single cathode ray oscilloscope where we are having the green color line, and that will give the output and then we trace it. But here we are having the colored CRT monitors also. So the colored CRT display is a device used for presenting information to the user. So CRT produces the images by projecting an electron beam onto the screen and using a phosphor color to produce the color or the light. So a color television display often refers to a TV or simply the telly is an electrical appliances that emits the image in order to present the content predominantly as the part of consumer media rather than the professional equipment. Although color televisions were used for the first time in the Europe in 1928 and the North America in 1929, the first commercially successful television which could be purchased by the consumer was not available until the 1939, that are the colored TV, that time it is known as the colored TV. So colored CRT, that is the colored CRT monitor, because we are using the cathode ray tube, but to getting the color the phosphor was used in it. The use of electronic devices for displaying information has become less common with the advance of the computer and other digital media, but television are still very popular. So CRT standards for cathode ray tube display devices that uses a focused beam of the electron to produce the image. The image can be transferred into the various other output devices like video projector, computer monitors or the digital television. The display is built of colored phosphor dots or the diode. Phosphor dot or the diode. So each dot is called the picture element or the PEL for the short. Picture element used for the display devices. Moreover, what is the history behind it? First attempt at creating successful color television display date back beginning of the 20th century, where a color television display that was based on the rotating disc with 3 color filters element. And what are that 3 color filter element? That were red, green and blue. However, this system has too low or having a very low resolution for the practical use that at that time. Other attempts to create the television display were made throughout the 1930, but became commercially successful due to the various physical defect in the devices. After that, 1950 and 1960, the television with multicolored CRT, it means the multicolored CRT existed in the year of the 1950 and in between that 1915 and 60, that produced the colorful images, but the display devices was not easy to operate and of the low quality, especially compared to the regular black and white TV sets. As a result, the colored television sets sales did not reach large as early 1960s. So in 1968, the company Sony Corporation of Japan demonstrated a prototype for a color television that set a new type of the colored CRT, that is known as the ECRT, which later became known as the EDS, that is the electronically scanned displays, because it uses the electron gun instead of the phosphor dots as a other devices. So that is the EDS, electronically scanned display, instead of the phosphor dots. So what is the working of it? EDS CRTs emit electron beam and the electron leaves the cathode of the CRT at a certain angle. When the beam hits the phosphor dot, the signal shifts to the another color. This working is of the EDS, where the CRT emits the electron beam and this electron leaves the cathode of the CRT at a certain angle. And when the beam hits the phosphor dot, the signal shifts to the another color. With the several layers of the phosphor, one can produce the multicolors, and the brightness of each color is controlled by the color wheel, that sometimes called the color wheel. The image produced in such TV display needs to be converted into a digital format because before it can be displayed on the computer, on the mobile devices, and this is done by the special making pattern on near the screen, and that is known as the luma and chroma. So, luma is used to represent the brightness information in an image. If we present the brightness, then we use the word luma, and while the chroma represent the color information. Represent the brightness information luma, but the color information by the chroma. The luma pattern on the CRT display consists of two vertical strips, one dark and one bright, that will define the brightness information of the screen. So, it is usually placed where the center of the picture is located. For example, between the two vertical strips indicating fine horizontal lines of a black and white images. As such, it can be scanned by the TV tuner card, that is a TV tuner analog to the digital converter with the minimum loss of the resolution. So, you see on the screen here we are having a 3, this is the shadow mask, and you see electron beam which is passing from the 3 gun, which is red, green and blue, then passing from the shadow mask, after that the scan with the RGB phosphor dots, and this is the points. So, we discuss further in the next lecture the types of the CRT, how we use the basic method are used for producing the color displays, that we will discuss in the next lecture. Thank you very much.